Good morning, everybody. Um, Ramadan Kareem to everybody. Today's lecture, which is session 2 for Perkins 4000 series engines. In this session, we'll be talking about how to adjust the valves and the injectors for these Perkins 4000 series engines. There are two ways to make the adjustments, the short way method and the standard method. For today's lecture, we'll be going with the short way method, not the standard method. So let's start. We have two steps in here to go through to adjust the injectors and the valves. We have the calibration process, that's part one, and the other one that we'll be covering later is number two is timing process. So talking about the calibration process, um, in here, let me show you first the special tools that we'll be needing to do such adjustments. Here we go. We need the compressing bar and we need this special tool, okay? Plus, we need this turning tool, the bearing or turning tool, with which we can turn the engine through the flywheel side, of course. Okay, so again, at the moment, in the calibration process, we'll be using these two tools, the special tool and the compressing bar tool, going back all the way at the top. So in the first step, injector no fuel position. What am I talking about? In this calibration process, we'll be adjusting the position of the injector arm. Let me show what I'm talking about. This is the injector. This is the arm of the injector, okay? It has a starting point. If it's moved far away all the way to the other side, more fuel will be sprayed. So this is the one that will be controlling the fuel amount that should be sprayed through the injectors, okay? So going back all the way at the top again, in here, we'll be setting in step one, we'll be setting all the injector arms at the zero position. We call it no fuel position. So let's go step by step, see how this is done. First, we need to remove the head covers of all the heads and their gaskets, of course. Plus, remove all the rocker arms for the valves and the injectors as well. And then we use the compressing bars to compress the upper parts of all the injectors. Let me show you how this is done. Here we go. That's how it looks like. Okay. We mount the compressing bar and we compress with this bolt the injectors one by one. How do I know that I made the proper pressing on the injector? Live view. Uh, we move this link. You keep pressing with this bolt the plunger of the injector till you feel that this linkage is moving freely. That's how you know that you got the proper compression on the injector side. The purpose of using these compressing bars, whenever you compress the plungers of the injectors a little bit, to make sure that these linkages are moving freely. Because if you don't have a compressing bar, these linkages will not be moving freely. They will be stiff, hard to move. Of course, these linkages are connected to the control arm of the injector. So this is the first step. Put the compressing bars, compress all the injectors, and make sure that all the linkages are free, soft to move. This is the first step. Second step, we are still talking about the no fuel position. Here we go. So what we have done so far, we have taken off the head covers and their gaskets. We removed all the rocker arms of the valves and the injectors, and we compressed all the injectors. Now, we need to rotate the actuator shaft by 10 degrees. if I'm talking about Heisman governor. How do we do this? Using a special tool. You can make it yourself, like this one, pushing on the arm of the actuator side. We should read 10 degrees, just like in here, okay? Using this special tool. If we are talking about a 4000 series engine that has a PRO-ACT type of controller or governor, on the actuator side, you should move the needle by 4 degrees, not 10. The 10 degrees applies only to Heisman actuators. Again, we have already moved the arm of the actuator by 10 degrees. Of course, all the arms, the control arms on the injectors will be moved a little bit. Now, we'll be using this special tool. This is the special tool I'm talking about. Here we go. It should go around the control arm of the injector and use the mark B on the special tool. It should be matching with another mark on the injector tank. And the injector tank in here somewhere, we have a scratch. It's a mark. Both marks, the B mark on the special tool side and the injector tank scratch, which is the mark on the injector side, they should be matching perfectly, like this. Here we go. Just to make it clear, this is the good alignment. Okay, we should be having the B mark on the special tool matching with the scratch or the mark on the injector tank, like this. It's not acceptable to be like this or like this. What if the alignment is not found aligned properly? We should make adjustments. How will we do the adjustment? Again, going to the here. This is the linkage which is connected to the injector arm. With this, we can make the adjustment. I can increase the length of the linkage or decrease the length of the linkage to make the marks on the special tool and the injector arm matching perfectly. That's how the linkage looks like. Okay, with this, you loosen the two mounting bolts or the lock nuts, sorry, on both ends of these ball joints. And with this one, you turn either clockwise or counterclockwise to lengthen or to shorten the length of this linkage to make the control arm on the injector side using the special tool having both marks matching perfectly. So that's how we do it. Okay. Now, when we finish from using the special tool to make sure that all the injector arms on the zero, again, let me show you what we have done so far. We are here now. This is what we did. No fuel position. We adjusted all the rocker arm, all the control arms of the injectors at the no fuel position using this special tool. Next, we'll be going to step 2. Let's go to step 2, see what we do in here. Here we go. Step 2, we call it injector calibration position check. Again, this time we need to again rotate the actuator shaft with the special tool that I have shown you a few minutes ago. More than 10 degrees, of course. What we should do now, we should take injector number 1 as our reference and ask somebody to start pushing the actuator arm all the way till we see this. Let me show you what I'm talking about. Here we go. Here we go. This is the control arm of the injector. This is the linkage. This is the mark on the injector tank. What we need to see when you start, pushing with the special tool, the actuator arm, I need to see the back edge of the injector arm matching perfectly with this injector tank mark. That's what we need to see for all the injectors. Of course, we need to start with injector number 1. We should be having this matching perfectly like this. The back edge of the injector arm matching perfectly with the injector tank. Okay, scratch like this. Okay, when you finish with injector number 1, you go and check the rest of the injectors. They should be matching like this. If not, let's suppose that you found that this back edge arm has moved a little bit further. It's not matching perfectly with this one, or it is before the back edge of the control arm of the injector is before this scratch. You need to make adjustments. Let's mention here what you can do. Here we go. Check the rest of the injectors. If one or more injectors found to be overfuel, the back edge of the injector arm has moved further away from the scratch or the mark on the injector tank, you need to shorten with the linkage, okay, to get the proper alignment again. We cannot increase the length of the linkage. We can only decrease. Let me mention something. If I get to this mess where I have to, make adjustments in step 2, this means that I have screwed up the way I did step 1. Always, always. Let me show you again step number 1. Step number 1. Here we go. Always, always. If you get in injector no fuel position check, you get it perfectly aligned like this for all the injectors, like this, no way you will get messed up in step number 2. Okay, so that's what I do all the time. I make sure in step 1 I get perfect alignment with the special tool mark B with the injector tank scratch. Okay, if you do this for all the injectors, no way you will have any problems with step number 2, which is this one. Okay, I don't believe in this. If I get to this point where I have to make adjustments in step number 2 for some injector control arms, I will go again to step number 1 and redo step number 1. Okay, I will not mess up, with the injector arms in step 2, making shorten or lengthening the arms through the linkage. No way. Make sure that you get step 1 matching perfectly. And finally, step number 3, it's a double check. Again, the man who is controlling the turning tool on the actuator side, he should go back to 10 degrees position on the actuator side and double check using the special tool all the injectors. You should be having all like this, as we mentioned earlier. You should be having all like this, okay? If you have anything like this or this, it means you have done a bad job. In this case, you need to redo everything starting from step number 1. So that's why I'm saying make sure when you will start with step number 1, make sure you are getting these marks aligned perfectly. No way you will get into trouble when you go to step number 2 or to step number 3 when you make a double check. That's what I do. Always make sure that you get step number 1 perfectly matching like this one. You will not get into any mess. Okay, we have already mentioned this. Okay, we mentioned this. And finally, we mentioned that you need to go and double check. Make your actuator arm go back to 10 degrees and use this special tool to check again all the injectors. Again, I say this again, make sure when you do step number 1, which is the no fuel position, make sure you get all the marks matching perfectly using the special tool, as I mentioned before. Mark B on the special tool matching perfectly with the mark on the injector tank. Step number 1 is the most important one. Okay, when we do this, when we finish with this, you need to remount the rocker arms. All the rocker arms and tighten the bolts of the rocker arms. From one side, the shaft of the rocker arms, the 3 rocker arms, we have a rocker arm for the inlet valves. We have another rocker arm for the exhaust valves, and the one in the middle, the big one, it's for the injector. If you are working with an engine that has an injector which has a 14 millimeters plunger size, you tighten the stud and the bolt that are holding the shaft of the rocker arms by 240 Newton meters. If the injectors that you have on the engine are of the other type, which is a 12 millimeters diameter for the injector plunger, you use a torque of 125 Newton meters. So again, on these 4000 series engines, we have two types of injectors. One, which has a plunger with 14 millimeters diameter. For this type of injectors, you go with 240 Newton meters whenever you tighten the mounting bolts of the shaft of the rocker arms. If you have the other type of injectors, which is the 12 millimeters plunger diameter size, you need to go with half this much, 125 Newton meters. Okay, so here we have finished with the calibration process. We are done with the calibration process. Again, these are the special tools. We don't need these anymore. Now we'll be going to step number 2, which is the timing process. We don't need these anymore. We need this one instead, okay? With this one, now we need to turn the engine. As I mentioned, we are talking about the short way method, not the standard method. We can go through the standard method in another session. If somebody likes to know how to do it, to do the adjustments, all the adjustments, both methods, we can make another session next time to show how we go with the standard method. But for this lecture, it is going to be the short way method. This is what we are using as Jubaili. Okay, the timing process now, short way method. In this process, we will be adjusting the valves clearances and the injector timing pin. All these are carried out at the same time. As an example, we will go with the 4006 engine, just for simplicity. I'm not going to talk about the 4012 or the 4016. I'll go with the 4006 just to make it simple. Okay, we need to mention something about, the flywheel on the 4000 series engines. On the flywheel side, we have two types of marks. We have the TDC marks, like this one here, TDC 16, TDC 25, and TDC 34. We have 3 TDC marks on the flywheel of the 4006 engine. Plus, we have other marks on the flywheel side as well. We have, let me show you what I'm talking about. Here we go. This is the TDC mark, okay? This is the guiding pin, okay? These are the TDC marks on the flywheel side. Just before the DDC mark on the flywheel side, we have other marks. We call it spill timing marks. You will be seeing more than one mark, and you will see numbers, degrees, like 18 degrees, 20 degrees, 22 degrees. Okay, which one should I go with? You need to go to the engine nameplate, which is mounted on the engine block. On the nameplate, you will see two things. You will read the engine serial number and the spill timing. It might say, for example, spill timing is 20 degrees BTDC before top dead center. So you need to go with the 20 BTDC mark on the flywheel side. So you choose the 20, not the 18, not the 22. You go with the 20. These marks, the spill marks, they come before the TDC mark. So in here, for example, if I turn the flywheel, usually we turn the flywheel from the control panel side counterclockwise. So this is what you will see first. You will see the spill timing marks on the flywheel, let's say for pistons 1 and 6. Afterwards, when these marks have already exceeded the timing pin here, this mark, you will see the TDC 16 mark. So that's how it goes. You will see these timing marks, spill timing marks, before you see the TDC mark. So again, let me show you this table is for the standard method. We will not talk about this one. We will go with this table. This is for the short way method, only 2 columns. Okay, but again, I'm not going to go with the TDC mark. I will go with the spill timing mark, okay, which I showed you. As an example, we mentioned, let's suppose that the spill timing mark is 20 degrees before top dead center, which you read from the engine nameplate. So you start with the spill timing, not the TDC mark, okay? So let's suppose that we got to spill timing mark 20 for pistons 1 and 6. You go to piston number 1 and 6, you check which one is rocking, which one is on compression. Let's suppose in here, when you got to the spill timing mark at 20 degrees BTDC, our example, for 1 and 6, 6 is rocking, 1 is ready. It's on compression. So what you do, you adjust the exhaust and inlet valves of piston number 1. How much is the valve lash? It is 0.40 millimeters for the inlet valve and the exhaust valve as well. This valve lash number, the 0.40 millimeters, applies to all the 4000 series engines, whether it's a 4006, 8, 12, or 16 cylinders. Okay, so let me go back to the text and see what we do. Again, reading this. On the flywheel side, there are TDC and spill timing marks. As I mentioned, we need to go with the spill timing marks for the short way method, not the TDC. We turn the engine twice, we adjust all the valves and all the injectors, okay? That's how it goes with the short way method. In the standard method, we turn the engine 4 times, not 2 times. We are not going to go into details for the standard method. We'll go with the short way method. So again, we will be going with the spill timing marks, okay? To adjust the valve clearances, which we have already mentioned, should be 0.40 millimeters, and the injector timing pins at the same time. Let me show you how we do the injector timing pin. So let's suppose for 1 and 6, 6 is rocking, 1 is ready. We adjusted the valves, the inlet and exhaust valves of for piston number 1 at 0.40 millimeters for each. Next, at the same time, I adjust the pin of the injector number 1. Let me show you how we do this. Let me show you the injector first. Here we go. This is the injector. The rocker arm at the top in here will be pushing the plunger down. This is the control arm of the injector again, and this is the timing pin. Okay, so how we do the adjustment, that's how we do it. This is the rocker arm of the injector. This is a lock nut, and this is the adjusting bolt with which you can compress or release pressure on at the top of the injector plunger. Okay, so you release the lock nut. In here, you put an Allen key, 3 millimeters Allen key, with which you can turn clockwise or counterclockwise. Okay, and using a screwdriver, you push sideways on the pin of the injector. So as a start, you release the lock nut, you untighten, go counterclockwise for the bolt, loosen the bolt all the way up. Okay, next you bring the screwdriver, you push sideways on the pin, okay, and you start tightening the bolt slowly, going slowly. You will get to a point when you will feel with the screwdriver that the pin has got in, it will be engaged, going in. Okay, so when you got to this point, you stop, you go counterclockwise, loosening the bolt. That's what I mean by counterclockwise. You loosen the bolt, going backward counterclockwise slowly. When you go slowly, you will feel that the bolt is going soft, very easy. This means that that's an indication that the pin has been engaged in and locked. It will not go out. So you take off the screwdriver, you will feel that you can see that the pin is locked in. Okay, it's not out anymore. It is locked in. So now I don't need the screwdriver anymore. Again, I start to tighten this bolt slowly till you hear a clicking noise. The clicking noise means that the pin has got out again. Okay? So when you get to this point, you stop, and the final step with the Allen key, this one, you tighten the bolt 2 full turns. This is the equivalent of pressing the plunger down by 3 millimeters. So that's how it is done. Okay? Let's see the text that I have mentioned here, how to do this. Here we go. Again, rotate the flywheel anti-clockwise from the control panel side, of course, okay? And you will be seeing the spill timing marks for pistons 1 and 6 before you see the TDC 16 mark, okay? So go with the spill timing mark. Our example was the 20 degrees BTDC mark that you read on the engine nameplate. This is the mark that you will be going with. When you get the 20 BTDC mark on the flywheel side for pistons 1 and 6, you stop, you adjust the valve lashes for inlet valves and exhaust valve of piston number 1. This is how much is the valve lash, 0.40 millimeters. When you finish, you go to the injector now, injector piston number 1. Again, you release the lock nut, okay? Loosen the bolt at the tip of the rocker arm all the way up. Then you bring a screwdriver, you push sideways on the pin of the injector, and you start to tighten the bolt slowly till you feel that the pin has entered partially. Okay? When it gets in, you stop. Okay? You keep pressing on the pin with the screwdriver. Okay? Now with the bolt, the tightening bolt at the tip of the rocker arm, you start loosening the bolt. Okay? You will feel that it's going free whenever you start loosening the bolt, going counterclockwise. This means that the pin has engaged in. It's locked in. It is engaged. You take off the screwdriver. No need for the screwdriver. Okay? And finally, you start tightening the bolt again, but going slowly till you feel that the pin has got out again. How do you know it got out? You can hear a clicking noise. Click. This means that the pin has got out. Okay? So you stop. From this point, you tighten the bolt at the tip of the rocker arm of the injector 2 full turns. This is the equivalent of compressing the injector plunger down by 3 millimeters. When you finish from piston number 1, let me go back to the table. You turn the engine again, the flywheel side, of course. And next, you will be getting to the spill timing mark 20 BTDC for pistons 2 and 5. So if it was 1 ready at the first step, 5 will be ready now, okay? So you adjust the inlet and exhaust valves of piston number 5 and the injector as well of piston number 5. When you finish, you turn the engine again till you see the spill timing mark 20 BTDC, but this time for pistons 3 and 4. The 3 will be ready, 4 is rocking. So you adjust the inlet valves and exhaust valve of piston number 3, and at the same time, you adjust the injector as well. When you finish, you have already turned the flywheel 360 degrees, 1 full engine turn. Now you will be turning the engine again, but this time, whenever you get to the spill timing mark 20 BTDC for TDC 16, it will be 6 ready, 1 rocking. So you adjust the inlet valves and exhaust valves of piston number 6 and injector number 6, and so forth till you finish up. So to complete the process, the engine will be rotated twice, okay? And you will be adjusting the valves and the injector pins and plungers at the same time. This is the short way method. That's how we do it. Okay? So we can take questions now. What about engine temperature? If I'm not mistaken, you mean, can we do this when the engine is hot? If this is what you mean by this question. Usually, for all engines, it is better, and it is better to adjust valves, injectors, whatever, when the engine is cold, not hot. Okay, why? Because all the parts are made from metals. When the engine is hot, metals will expand, so you'll not be getting precise adjustments. So that's why it is better to do this whenever the engine is cold. Besides, if the engine is hot, you will be burning your hands. So for all engines, it is better to do adjustments whenever the engine is cold. Another question. No, no need to warm up the engine. We do this kind of process whenever the engine is cold. We do not warm up the engine. No need for this. Another question. Okay, thank you all for. Okay, what about if I remove thermostat to this engine? No, it is not recommended to remove the thermostats for any engine. What is the role of the thermostat? The role of the thermostat is to regulate the engine temperature, to make sure that the engine is running at like 75 to 85 degrees Celsius. If you remove the thermostats, your engine will be running at very low temperatures. In this case, it might not take impact loads, and the engine definitely will be consuming more fuel. For any engine to work efficiently, it must be running at a certain temperature. You must not take off thermostats. Okay, any other questions? Okay, thank you all for joining this session, and hopefully next time we can talk about the standard method.